Assalamualaikum warahmatullahi wabarakatuh to Dr. Abu and everyone. We are from Group 7 and in this video, we would like to present our microcontroller mini project titled Online Garage Door Opener. Our group members are Amni Afika, Azrin Izati and Dexy Owen. Without further ado, let's begin with the components used in our project. These are the components used in our project. The main controller is the ESP8266 Node MCU, which processes the commands received from the Blink application through a Wi-Fi connection. Next is the SG90 servo motor, which simulates the opening and closing movement of the garage door. We also use jumper wires to connect the servo motor directly to the ESP and a USB cable to provide power to the board. Now, let's move on to the circuit connection. First, the jumper wires are connected to the ESP. After that, the other ends of the jumper wires are connected to the servo motor. The SG90 servo motor consists of 3 pins, which is the signal pin, VCC pin, and ground pin. The signal pin is connected to digital pin D4 on the ESP to receive the control signal, while the VCC pin and ground pin are connected to the 3V and ground pins respectively to provide power and complete the circuit.
Next is the programming section. First, the program imports the required libraries, including the ESP8266 Wi-Fi library, the Blink library, and the servo library. After that, the Wi-Fi SSID, password, and the Blink authentication token are configured. This setting allows the ESP8266 to connect to both the local Wi-Fi network and the Blink cloud server. After that, the servo motor is initialized and attached to a digital pin D4, which is used to send control signal to the servo. The main function used in this project is the Blink Write V1 function. This function receives the input from the switch widget in the Blink application. When the switch is turned on, the ESP8266 sends a command to the servo motor to move to the program open section. When the switch is turned off, the servo programs returns to closed position. To create a smoother and more realistic movement, a short delay is added between each step of the servo rotation instead of moving instantly.
Now, this is Blink dashboard used to control our project. The dashboard contains a single switch widget that controls the movement of the servo motor. Before the garage door can be controlled, the ESP must first connect to the Wi-Fi network. Once the connection is successful, the device status in the Blink application changes to online. When the user turns the switch on, the servo motor opens the garage door. When the switch is turned off, the servo motor closes the garage door. This simple interface allows user to operate the garage door remotely from anywhere with an internet connection.
The following video demonstrates the operation of our home garage door opener system. First, the ESP is powered on by connecting the USB cable. Once powered, the ESP automatically connects to the configured Wi-Fi network and the Blink cloud server. When the connection is successful, the device status on the Blink dashboard changes to online, indicating that the system is ready for operation. Next, we demonstrate the operation of the system using the Blink dashboard. When the switch is turned on, the ESP receives the command and the servo motor opens the garage door. When the switch is turned off, the servo motor returns to its initial position, closing the garage door. After that, we demonstrate the same operation using the Blink mobile application. The garage door is opened remotely to allow a vehicle to enter the garage. Once the vehicle has entered, the garage door is closed again using the application.
In conclusion, this project successfully achieved its objective by developing an IoT-based garage door opener using the ESP8266, Node MCU, and Blink IoT platform, and an SG servo motor. The ESP8266 successfully connects to the Wi-Fi network and receives command from the Blink application. The servo motor responds correctly by opening and closing the garage door according to the user's input. Overall, this project demonstrates how IoT technology can be applied to create a simple, convenient, and remotely controlled smart home system. Thank you for watching.